In this video I'm going to talk about ways of using SPSS to represent data that are scaled at a nominal or ordinal level of measurement. So I have two variables in my data set. So let's say that 20 individuals, let's say I asked 20 individuals off the street corner what their eye color was and whether or not, or what year in school. Let's say I was only asking people who I assume to be college students what year in school they are. So in these cases I've got one variable that I'm treating as nominal, the other variable I'm treating as ordinal. So let's take a quick look at the data the variables and how they're set up to get a feel for them before we start looking at ways of representing them. So if you utilize this little toggle at the bottom of the SPSS screen, you can move between variable view and data view. Under variable view, this is where you name your variables and assign different characteristics to your variables. So I've assigned, for the type of variable, I've assigned numeric to them. That's actually the default in SPSS, but there are other ways of assigning the type of variable as well, but this is by far what most people utilize and what I utilize. Under values, this is where you can assign value labels for your observations. Or basically it's like this. If I'm asking people about their eye color, I might say, well, do you have green eyes, blue eyes, brown eyes, or some other color? And so they might indicate whether they have green, blue, brown, or other color. And instead of having to type in green, blue, brown, or other, what I might do is assign a numeric code to each of those categories, so that when I enter the data, I can just enter the actual number associated with their response. And the nice thing about, and I don't have to use the value labels to do that, but by doing this, by assigning a code to each value that a respondent could give, these values will show up in any output that I request related to the distributions of the eye color variable. So that's one of the nice things. Otherwise, I would only get 1, 2, 3, or 4, and then I would have to remember what those actually stood for. So this is a nice thing to have. For the eye color variable, it's treating it as nominal. If you click over here, you can see I've clicked on nominal. For the year in school variable, I've assigned value codes for that as well, or value labels for that. So 1 is being treated for freshmen, sophomores are 2s, juniors are 3s, and 4s are seniors. So, and this variable is being treated as ordinal. If I had a variable that I was treating as interval or ratio and level of measurement, I would be using scale, but I'm not, so I'm using ordinal for that. So let's look at representing the data in terms of frequency, relative frequency distributions, and different graphing options. So let's start off with eye color. So let's go to descriptives and frequencies, and I'm going to move eye color over, and there are several options here. One of the options is I can ask for certain types of statistics associated with this particular variable. And really there are no meaningful statistics that can be computed on a nominal variable except the mode, which would be the measure of central tendency. And so the mode is just basically the category that occurs most often in the data, so, or the most frequently occurring category. So that's about all I can ask for in terms of the measures of central tendency. Now the more interesting thing in terms of charts, I can ask for pie charts and bar charts. Either of those will work with the nominal variable. So I'm going to go ahead and ask for pie charts. And I have two ways in which the pie charts can be, or bar charts for that matter, can be represented. I can either use frequencies or percentages. I'm going to leave it on frequencies for right now, and then I'll show you later with percentages. So we'll click on continue and then OK. And you can see right here that we have, first of all, you can see we have a frequency distribution associated with each value of our variable eye color. Like I said, if I had not assigned value labels earlier on, then I would just get a 1, 2, 3, and a 4, and then I would have to try to remember what those codes actually represented. So this is a nice thing behind doing that. So I've got frequencies, and then I've got percentage of observations that fall into those categories. And the percent and valid percent columns will basically be exactly the same in terms of the values when there's no missing data. If there are missing data, then actually there will be another category which would be listed that will say missing data, and there'll be a percentage associated with that. So if I'm not interested in including the percentage of missing data in terms of talking about the percentage of observations falling into these categories, and I just want to focus on those observations that have the complete data on that variable, then I would focus on the valid percent column. The cumulative percent column just is really irrelevant in the context of a nominally scaled variable, so just completely ignore that altogether. Here we have our pie chart, and as you can see, each of the pieces of the pie represents the amount of, or the proportion of the total that is captured by those categories. So you can see that proportionally speaking, the blue category had the greatest frequency, had the greatest percentage of observations falling into that category, so obviously that was the biggest slice of the pie, followed by the greens, which you see right here, followed by the brown, and then followed by the others, which you see right here. If I want the actual counts listed, what I can do is I can click on the figure, double click on it, and then right click on the figure in this box right here and go down to show data labels. And by default it says displayed the count, because that's what I'd asked for earlier when I ran the analysis. So now when I click on close, these are the frequency counts associated with those different categories. If I wanted instead, I want percentages, then I could actually remove the count and just add percent and move that up, and that way I get the percentage of observations that fall into those particular pieces of the pie. So you can do it either way. So that's using the pie chart in SPSS with a nominal variable. Let's see what happens if I ask for a bar chart. So I'm going to go back, and instead of pie chart, I'm going to ask for bar chart. And I'll just go ahead and use percentages in this case. I could use frequencies. Along the y-axis, frequencies would be denoted, but in this case we're just going to use percentages. And as you can see, all this information is exactly the same as what we had before, but in this case I've got eye color, the different categories, and then the percentages along the y-axis. So like I said, you can use a bar chart or a pie chart when you're dealing with nominal data. Either works. So that's how you can run some of that data. Now let's see what happens if I want to look at our ordinal variable. So in this case I'm just going to reset everything, and I'm just going to move my year school variable over. Really, in terms of statistics, I can ask for the median and mode. The median is just basically representing the 50th percentile. So basically that point in the distribution that divides the distribution into equal proportions. So basically 50-50. So I can do that. I could still ask for the mode as well if I want to. So At any rate, let's look at some charts. You would not use a pie chart with ordinal data. So really the only logical chart you can use is a bar chart. So I'm going to leave it on frequencies for right now, and I'm going to click on continue and then OK. And so now we have our frequency distribution for the levels of our ordinal variable. We have the percentages of observations that fall at each of these levels. And now we also have a cumulative percent column, and this makes a little bit more sense in the context of an ordinal variable, because essentially we're going from low to high, representing potentially greater or lesser amounts of education. So for the cumulative percent of 35 right here, that would mean that 35% of the distribution falls at the freshman level. And really there's nothing preceding that, so that percentage is going to equal the relative frequency, or basically the percentage that we have right here. 70% of the distribution falls at the sophomore level or freshman level, so 35% of the distribution were sophomores, 70% falls at the sophomore level or the freshman level, 90% falls at the junior, sophomore, or freshman levels, and obviously 100% would fall at the senior level or below. So you can use the cumulative percent column to sort of get a better sense of what percentage of the distribution falls at or below certain points. So here's our bar chart, and as you can see, we've got our freshmen, sophomore, junior, and seniors listed along the x-axis, frequencies along the y-axis. You can see that we have equal frequencies for freshmen, sophomores, less of a frequency for juniors, and the least frequency for seniors. If we wanted to ask for percentages, obviously we could do that. And so here we have it. So these are the percentages associated with each of our categories on our ordinal variable.